Hello guys, so today we will discuss about exact differential and inexact differential, or state function and path function. Okay, so let's start the video. So for that, let us consider a property Z. Okay, this is a property, any property which is a function of x and y. Okay, right. Function of x and y. Now it depends upon x and y. If we change the value of x and y, this will considerably change. Now if we change x, okay, very infinitesimal change in x, then dz will be changed. Okay, so here dz is equal to at constant y. Okay, in this time we will assume that y is constant. Okay, just x is changed and its overall change in x, plus when we change y, dz will also be changed at constant x now, multiplied by its overall change in dy. Okay, now we will assume that this is m xy dx and this is n xy dy. Okay, now according to Euler's reciprocity relation, we will now have to differentiate with respect to this. Okay, we will differentiate it with respect to dy and this with respect to dx. Okay, so delta m by delta y at constant x is equal to, okay, is equal to delta n by delta x, this, okay, at constant y. So this is called Euler's reciprocity relation. And if a function shows this relation, then we will know that the function is exact differential or exact differential or state function. Okay, so we have now known that exact differential are those functions which depends upon state and not upon the paths followed. Okay, now we will check whether pressure is an exact differential or inexact differential. Okay, if it is exact differential, then the function will be state function, and if it is inexact, then the function will be path function. Okay, so we know for 1 mole of an ideal gas, PV is equal to RT. Then we can write it like this: P is equal to RT by V. Now we will write the differential equations for this. So if we change volume, okay, pressure will depend upon volume and temperature. It will not depend upon R, as we know R is constant, it is universal gas constant. So pressure will not depend upon this, but it will depend upon temperature and volume. If we change volume infinitesimally, okay, if we change volume infinitesimally, then pressure will also be changed at constant temperature. Okay, so now delta by delta V, P is what? RT by V at constant temperature. So T is constant, here we know that T is constant and R is also constant, then this term will go out, RT, and delta V inverse, okay, 1 by V, we can write 1 by V as V inverse. So RT, this term will come down, so V minus 1, so minus RT V to the power minus 2, or RT by V square. Okay, now we will check it for temperature. When we differentiate pressure with respect to temperature at constant volume, the delta by delta T, RT by V at constant volume. So R and V are two constants. So this will go out, R by V, and delta delta T T. This is equal to 1. So R by V. Okay, we have to differentiate this term with respect to this, and similarly this term with respect to this. Okay, you will now understand what I am trying to say. So this term with respect to this. Okay, so then what will happen? This dt. So we found the answer for it, RT by V square. So negative sign has gone out. So this is equal to, it was at constant volume, so this will be equal to minus R by V square. Okay, the same is applied here. When d 2p, this is not d, this is delta 2p, delta v, delta t. Okay, so delta delta v, so we found it R by V at constant temperature. R is constant, so this will go out, R delta delta V, V inverse, so R by R V to the power minus 2, and this will equal to minus R by V square. Okay, so now we have realized that this part and this part are two identical parts. Okay, we have also found R by, minus R by V square for this and for this too. So LHS is equal to RHS, and this is what exactly the Euler's reciprocity relation says. So we have come to know that pressure is an exact differential or a state function. Okay.